Unit 1, Factoring Polynomials. We have already added, subtracted, multiplied, and divided polynomials. Now today we are going to work backwards and factor the polynomials. Different ways for factoring. Number 1, greatest common factor. 2, difference of two perfect squares. 3, trinomials. And 4, combination of all the above, factoring completely. So the first one we're going to look at is greatest common factor, which is also known as GCF. Two things that we're going to look for when we're factoring by our GCF is 1, you're going to look for the largest number that goes into the numbers evenly. And number 2, you're going to look for a common variable that they have. If they have a common variable, then you're going to take the one with the smallest exponent. So example 1, 6x plus 12. You're going to look at 6 and 12, and you're going to see what is the largest number that can go into 6 and 12 evenly. 6 is our largest number that will go into it evenly. Now, do they both have a variable? No, only the 6 does. So once you have your greatest common factor, in this case, which is just 6, you're going to divide both terms by that greatest common factor. So 6 divided by 6 is 1, and we have an x left, so we can just write x. You can put 1x. Then you have a positive 12 divided by 6, which is a positive 2, and that is that factored. Now you can check to make sure you're right by multiplying the 6 through. So to check it, you're going to take the 6, multiply it by the x, and you get 6x. Then you're going to take the 6, multiply it by the 2, and you get 12. That is what we started with. Example 2. 9a squared plus 18a. Now you're going to look for the greatest common factor. What is the greatest common factor of 9 and 18? It's the largest number that goes into 9 and 18, which is 9. Now you're going to look, do they both have the same variable? They do. They have, one has an a squared, one has an a. But we can only take out the smallest exponent. So we're going to divide each term by our GCF. So now 9 divided by 9 is 1. You can put the 1 in. And then you have a squared divided by a. Remember, with dividing, you subtract exponents. So if I have two a's on top and I take one, I have just an a left. Now I have a positive 18 divided by 9, which is a positive 2. And then I have an a, so it's 1 minus 1, which is 0, so the a's cancel. Example 3. 21x squared y to the third minus 7xy plus 14y. Now you have 3 terms. Same steps. Find your largest number that will go into all 3 of them, which is 7. Now you're going to look, do they have common variable? They do. They all have a y. Well, what's our lowest exponent, which is the 1. So now you're going to divide each one by our GCF. 21 divided by 7 is 3. And then you have an x squared. Well, you're not dividing it, so the x squared stays. And now you have y to the third divided by y. So 3 minus 1, which is, you have 2 y's left. Now your middle, make sure you take the sign with it. So -7 divided by 7 is a -1. You have an x on top, and then you have a y divided by a y. So 1 minus 1 is 0, so the y's cancel. And then your third term, +14 divided by 7 is a +2, and again, the y's cancel, and that is your answer. The second way we're going to look at is difference of two perfect squares. Now, perfect squares are made by squaring any whole number. So if you start with our first whole number, which is 1, 1 squared, or 1 times 1 is 1. Then go to 2, 2 squared. So 2 times 2 is 4. Go to 3. 3 squared is 9. And then keep going. 4 squared is 16. 5 squared is 25. And then do 6, 7, 8, 9, 10, and you can keep going. Those are perfect square roots, because like the square root of 4 would be 2. So they're perfect square roots. They come out evenly. Now looking at variables. Any variable that has an even exponent is a perfect square root, and you can keep going. So if it has an even exponent, it is a perfect square root. So let's look at the first example. Y squared minus 64. Y has an even exponent, so it's a perfect square. And 64 is a perfect square because what number multiplied by itself or squared gives me 64? Which is 8. So let's look at the y squared. What times what's going to give me y squared? Y. Now it needs to multiply to give me a -64. So our signs have to be what? A positive and a negative. And then what number squared gives me 64? 8. So that is factored. That is the difference of two perfect squares. Now this works because if we use double distribution to check, let's check this answer just to make sure that it's correct. So we're going to start with our y. Y times y is y squared. Then we're going to take y and multiply it by -8. So you get -8y. Now start with the 8. 8 times y is a positive 8y. And then 8 times -8 is -64. Now when we get to this step, we need to combine like terms. So right there's our like terms. What is -8 plus 8? Well, it's 0. So they cancel. So you're left with y squared minus 64. That is why it's a difference of two perfect squares. Your middle term is going to cancel. So let's look at the next one. 9x squared minus 25. So 9 is a perfect square root. X squared is a perfect square root. And 25 is. So let's factor it. Let's start with a 9x squared. What number squared is going to give you 9? 3. What times what's going to give me x squared? X times x. Now it needs to multiply to give you a -25. So again, our signs have to be a positive and negative. And then what number squared is going to give you 25? 5. And that is your answer. Let's do another one together. Number 6. 16x squared minus y to the 4th. So 16 is a perfect square root. X squared is. And then y to the 4th is also because y. it's got an even number as an exponent. So if there's even numbers, then they're perfect square roots. So let's start with 16x squared. What squared is going to give me 16? 4. And then x and x, and then it has to multiply to give me a negative. So you need a positive and a negative. And then y to the 4th. What times what's going to give me y to the 4th? Y squared. Good. All right, let's move on. The next way is trinomials, where you have 3 terms. If you remember, we need to multiply to come up with the 10 and add to give me the negative 7. So I use an x to figure it out. The top number is going to be what you need to multiply. So I'm going to put 10 there. On the bottom, I'm going to put what you need to add, which is negative 7. Now you're going to think of all the numbers that multiply to give me 10 that I can use to add up to give me negative 7. So you're going to multiply to give you a positive. So if it needs to be a positive, both signs need to be the same. So we're going to use negative 5 and negative 2 because they multiply to give me a positive 10 and add up to a negative 7. So you have 2 parentheses. What times what gives me x squared? Going back up here, x and x. And then what you got on each side is what you're going to plug in to the parentheses. So minus 5, minus 2, and now it is factored. You can check these by doing double distribution to make sure you come back to the same one. Number 8, x squared plus 2x minus 35. So again, let's make our x. Top number is what we multiply. What do we multiply to get? Negative 35. Bottom number is what we add, which is a positive 2. So if I ask to multiply to give me a negative 35, the signs have to be what? A positive and a negative. Now we're going to look through and figure out what numbers multiply to give me 35. Well, 1 and 35, and 5 and 7. Now which ones would come close to giving me 2? Right, the 5 and the 7. So now it needs to be a positive 2. So the larger number is going to go with the positive. And then the smaller number is going to go with the negative. Because 7 plus a negative 5 is a positive 2. So your parentheses again. Going back up, what times what gives me x squared? X. And then what you wrote here is what you're going to fill in. Plus 7, minus 5, and now it's factored. Now, factor completely. This is where you're going to look every time because you don't know. They're going to be mixed up. You don't know which way you're going to factor. So you want to always ask yourself, is there a greatest common factor? Now looking at number 9, is there a greatest common factor? Two is our greatest common factor. So if I divide, now is there a variable? No, because the 30 doesn't have an x. So I'm going to divide everything by my greatest common factor. When I do that, what am I left with? X squared minus 8x plus 15. Now you're going to ask yourself, x squared minus 8x plus 15. So can this be factored again? Yes. So we're going to make our x, because it's a trinomial. What does it have to multiply to give you? 15. Add up to negative 8. So if it's a positive multiplying to give you a positive, signs have to be the same. So which two numbers multiply to give me 15 and add up to 8? 3 and 5. So now we're going to bring down the 2. And then what times what gives me x squared? X. So x minus 3, x minus 5, and it's factored completely. And then let's look at number 10. Same thing. Is there a greatest common factor? Yes, there is. 4. So divide each thing by 4. What are we left with? 9 minus y to the 4th. Now you're going to look at this. Can you factor that farther? It's not a trinomial, but what is it? Difference of two perfect squares. So you're going to bring down the 4. And then what squared gives me 9? 3. Multiply to give me a negative. Positive and a negative. And then what gives me y to the 4th? Y squared and y squared. And that is your answer. Now I want you to try these 3. Pause the video, work them out, and then when you have them worked out, turn the video back on. These are the answers to the 3 that you just worked out. Tomorrow in class, we will practice more of this.